Let's look at some of the advanced features of members in VisualAnalysis. We have a simple portal frame here and with the member local axes shown. If we select the member, the beam across the top, and look at the properties we have over in the Modify tab of the Project Manager, the first thing I want to point out is the connection type. By default, it's set to Rigid Connect, which simply means there are no member end releases. I can choose a Simple Connect, Simple Rigid, or Rigid Simple, and when I do that, I effectively set up a shear tap connection for the Simple Connect. If you take a look at the releases down below, you will see that weak moment, strong moment at first end, weak moment, strong moment at second end are both released. So that's a very quick way to set up member releases. Other things I'd like to demonstrate are the one-way and two-way action settings. If I have a member, for instance, a brace that might be tension only, I can select that member and then change its action to tension only or possibly compression only. When I do that, I will force an iterative type nonlinear solution to get results. The other things we can look at are the offset values. The offsets allow the member to be moved away from the node in local coordinate directions Y and Z. For example, if I move the beam down a foot in the Y direction, when I do that, you see visually how the beam is moved. Offsets might be used for a situation such as a shear tab connection where I want to have the beam lowered so that the top of the column is even with the node level or column level. The effects of doing this in the analysis are that the member stiffness will be affected by the transformation effect of moving the centroid of the cross section. Another way to move the beam down is to select a project setting. So with nothing selected, I look at the Project Manager, and under Miscellaneous, I have an option to set the beam tops at nodes. So when I do that, we see that the beam gets offset by a distance of depth over 2. So that's a quick way if you'd like to move your offsets without having to manually set them. Another thing I'd like to show, which is an advanced feature for a member, is its end zones. By default, there are no end zones, but if I select an end zone for, say, the start of the member, I have the ability to say it's a rigid end zone, and if I do that, it defaults to a width of 1 foot, and visually you can see a block showing here. That means we are moving the end of the beam over 1 foot, and over that length it's rigid, so we're going to put a short little rigid link in that internally for that effect. A reason you might do this is if, say, the concrete column was connected to by a steel beam and we had a shear plate welded and the beam welded to the shear plate, and that was offset by half the column distance. So to do that, then I would enter an end zone 1 foot. You have some additional flexibility in that you can say this end zone is not 100% rigid, but rather a percentage of the beam stiffness. Defaults to 100%, so effectively you have no end zone. But if you wanted to put in a short, flexible piece, you could specify the length of the piece and then give a percentage of the beam stiffness to use for a spring that's used in that short piece. Final thing that's an advanced member feature is the ability to do a semi-rigid end connection. Semi-rigid end connections can be used for both the start and end rotations, R, Y, and RZ. And again, these are local coordinate rotations. The options we can look at are a constant semi-rigid end. So if I were to select that, I can enter a spring stiffness to use for the connection of the beam to the column. I can also use a bilinear type stiffness where we have two constants of stiffness, K1 and K2, to use in the moment at which the bilinear curve changes. And lastly, more complicated, I can use a power model type semi-rigid end. And for more information about these, I encourage you to look at the help file where these are described in detail.